Okay, ladies and gentlemen, here we go. Let's take a look. I solved it using secants and tangents, but some of you maybe, I don't like that. And you'll notice it kind of got long because I wasn't quite sure where to go with it. Ladies and gentlemen, that is this process. You must have a few successful failures. The idea that you're going to start and go from point A to point B in the most efficient way possible is a lie. That's not how life works. That's not how learning works. So let's go back and look at it a different way as well. Maybe you'll like it better. You'll notice I tried turning them into sine and cosine, then I abandoned my efforts, okay? Well, let's go back and let's try it again. Let's try it again with sines and cosines. And in this particular case, I could subtract 1 over cosine from both sides. 1 over cosine theta from both sides. And that gives me negative 1 over cosine theta equals cosine squared theta plus sine theta over cosine theta. Now, at this point, oh, wait a minute, it's not squared, it's just cosine theta. Now, at this point, I still have the same problem I had with tangents and secants. So let's go ahead and square both sides. All right, let's square this side. Let's square this side. Now, of course, the rules of exponents mean give it to the top. The negative becomes positive because negative 1 times negative 1 is positive 1 over cosine squared theta equals, and then over here we come up with cosine squared theta plus 2 cosine theta sine theta. That ought to start looking familiar to you now. And sine squared theta all over cosine squared theta because I give it to top and give it to bottom. Now for the top, because it's a binomial, I had to FOIL it. All right. At this point, if I have cosine squared plus sine squared, that equals 1. So cosine squared sine squared equals 1. So I have 1 equals 1 plus 2 cosine theta sine theta all over cosine squared theta, all over cosine squared theta. But again, fractions tell me that if I have two fractions that are equal and the denominators are equal, what must be true about the numerator? And the answer here is 1 equals 1 plus 2 cosine theta sine theta minus 1, gone, 0 equals 2 cosine theta sine theta, divide by 2. And now, at this point, I have 0 equals cosine theta sine theta. So, at this point, I break them up. Cosine theta equals 0, sine theta equals 0. Now, where does sine theta equal 0? Sine theta equals 0 at 0 degrees and at 180 degrees. Cosine theta, now primary value is at 0. Cosine theta equals at 90 and 270. But remember, this is what we've been talking about dividing by variables. How come I'm crossing every one of those out? Well, because I cannot have cosine theta equals 0. Otherwise, way up here, I'm dividing by 0. So even though I got these answers, they're extraneous. They're no good. Now, sine theta equals 0. Sine theta equals 0. I got 0 degrees or 180 degrees. Now, let's compare that to what I got when I used the secants. So I got secant equals 180 degrees. So that one is the case. But what happened to this whole 0 thing? How come I got a 0 here and I didn't here? Well, when I square both sides, you'll notice this negative went away. Okay, that negative went away. And so by squaring things, sometimes we will get extraneous solutions or we'll eliminate solutions. The only way to tell would be to take both of these items, put them back in the original problem, which would be way back up here, and determine which one would actually fit and be correct. We already know that we can't have 90 and 270 because that will make this undefined. So you need to take 0 and 180. So Again, they're not going to be that straightforward. You're going to have to work at it. Just because you can't get from here to here does not mean in any way that you have failed or that this stuff is too hard. It means you have to use what you know and figure it out. And it's a bit of a puzzle. And that's what some people actually love about math. I know, weird, right? So with that, there should be a couple help videos.